Welcome to Chapter 5, chapter discussing the periodic table. First thing we're going to look at in this chapter is the history of the periodic table, who was the first individual to put it together and how it's evolved since that time. And then the second part of the chapter will look at trends and properties and information that the periodic table can give us and how we can use the periodic table as essentially our best tool to learn chemistry. So let's start out talking about a gentleman by the name of Dmitry Mendeleev. He was a Russian chemist in the mid-1800s, and at that time there were about 40 known elements. And these elements just existed. People didn't have them in tables and charts, so Mendeleev was the first person to lay out these elements and see if there was any pattern or any specific chart he could make from these elements. And so what he did is he listed them in order of increasing atomic mass. He started with hydrogen, which was the lightest known element, and it went up to lead at that time, which was the heaviest element. And so he put them in order of increasing atomic mass, and he looked for patterns. And he did see that elements with certain properties reoccurred over certain numbers of elements. For example, every eighth element may have had a similar density or a similar way that it combined with oxygen or a similar melting point. And he noticed that these patterns existed as he listed all these atoms out. And so he put them in the groups, as you see here on the periodic table, which doesn't look anything like our modern periodic table, but it was the first table of organization for the elements. So Mendeleev's credited with organizing the very first periodic table. Now, it wasn't perfect. There were a number of discrepancies throughout the table, but we have to understand Mendeleev didn't know anything about protons or electrons or atomic orbitals. He just knew the physical properties that existed with these elements. Now, the interesting thing that Mendeleev did, if you could look on this chart in some places, specifically right here, that's a question mark. And by organizing these elements for the first time, Mendeleev was able to predict where certain elements should be. And one of these elements that he predicted ended up being germanium. And what he did, he took the properties of the element silicon, and he noted that 8 or so elements away, there should be an element with similar properties. And so he predicted the properties that this element should have, which he called ecosilicon. And about 15 years later, that element was actually discovered, and they named it germanium. So by putting together the first periodic table, Mendeleev was able to help the scientific community find elements a lot quicker because he had predicted certain properties and certain characteristics that those elements would have. And here is Mendeleev's second periodic table. Notice it's a little more organized into groups than the first one. Also, we're missing a whole group. The noble gases aren't there because they haven't been discovered yet. There are some elements with question marks by them, stating uncertainty. There are some elements here with dashes with approximate atomic masses here and here that Mendeleev said, hey, there should be some elements here, and hopefully we'll discover them in a short period of time. So this is where we started. And then in the actually right after the turn of the century, the mid-teens of the 1900s, a scientist named Henry Moseley was working with Ernest Rutherford. You might remember Rutherford discovered the nucleus of the atom. Moseley was his lab assistant. So Moseley then was the one who really discovered that the nucleus contains protons. So he's counting up these protons, and he says, you know what? The number of protons in an atom is equal to its atomic number. So what if we rearranged the table in order of atomic number instead of atomic mass, as Mendeleev had ordered it? So Moseley did this, and sure enough, rearranging them in atomic order resolved some of the discrepancies of Mendeleev's original table. So our modern periodic table that we have today is based on the arrangement that Moseley put together. And even if you look at our periodic table, there are some instances like between cobalt and nickel. Cobalt comes before nickel on the periodic table, but it has a higher atomic mass. And also tellurium and iodine. Tellurium has a higher atomic mass than iodine, but its atomic number is lower. And so those were a couple of the discrepancies that were contained in Mendeleev's periodic table, that by putting them in order of atomic number, those discrepancies went away. And this is what Moseley's first periodic table looked like. Still not quite like ours, because there were some discoveries of the atomic orbitals, the s, the p, the d block orbitals, which help arrange ours today, that Moseley didn't know about. Obviously, a number of new elements have been discovered. Notice here the noble gases all the way on the left-hand side, called group 0. Well, those noble gases are all the way on the right-hand side of the periodic table now, in group 18. And the periodic table is a work in progress still. Even though we've had the same one for many, many decades now, we're still discovering new elements, and they still may add on some elements and cause it to look a little bit different than the one we have today. And these are just some examples of some different periodic tables, the way we can write them out. Because there are periodic patterns, we can make a spiral periodic table. We can spiral out the elements from helium out to the heaviest. And notice they still align to their groups and their families. And this is a different example of how we can utilize the periods of the periodic table and put them from first period to second all the way down to the 7th period. And it's still an organized, unique pattern with periodicity, properties that occur periodically. Okay, so some basic organization of the periodic table, as we've discussed earlier in the year. It's divided up between metals, nonmetals, and metalloids. About 3/4 of the elements in the periodic table are metals. They are on the left-hand side. The nonmetals are on the right-hand side, mostly towards the top. And we got that zigzag line that splits those, and along the elements along those lines are called metalloids. They have properties of metals and nonmetals. And there are very few of those elements. If we look at the specific blocks of the periodic table, the s and the p blocks are what we call the main group elements, because if you remember talking about orbitals, the electrons filling the s and the p blocks are filling the main energy levels, the highest energy levels. Then we have the transition metals in the middle. If we're reading the periodic table from left to right, we are transitioning from metals to nonmetals. So that's why they're called the transition metals. And then the green ones that fit up in the transition metals are called the intertransition metals. These can also be referred to as the rare earth metals, or rare earth elements. Some groups have specific names, and you should know these names. You should recognize them, because we will be discussing them quite a bit. The group 1 elements, those are called the alkali metals. And the alkali metals are the most reactive metals. The group 2 elements are called the alkaline earth metals. Then we have the 3 through 12, which are the transition metals. Those haven't changed. The group 17 elements are called the halogens. Now these are the most reactive nonmetals. They react vigorously with the alkali metals to form strong ionic compounds, as we'll find out in the next chapter. The group 18 elements are called the noble gases. And they're called the noble gases because they're unreactive. And at the time they were discovered, the nobles were unreactive with the common people. They were stuck up, they were snobbish, they wouldn't intermingle with the commoners, and so they referred to these as the noble gases because they don't intermingle with any of the other elements. The groups 13 through 16, they really don't have names. They can be referred to as the boron group or the carbon group. But these are groups where at the top they are nonmetals, and at the bottom they're metals. So you transition as you go down the group from nonmetals to metals, different characteristics. The intertransition metals at the bottom, sometimes you'll see the top line of that referred to as the lanthanides and the bottom referred to as the actinides, named for lanthanum and actinium that they fit up in. But please make sure you know the names of these groups, so when we discuss them in class, you know what we're referring to and understand their characteristics. And here's another another chart, another way to look at those colorways.